Hello friends, this video on structure of atom part 18 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 17. Let's take one more example. What is the number of photons of light with wavelength 4,000 picometer that will provide 1 joule of energy? So, see, we have the wavelength of the light. So I can tell that one photon will provide energy that will be hc by lambda joules. So that will be, if you put the values, that many joules will get. Now n photons will provide n hc by lambda energy, and that is equal to n 1 joule. We have to find the value of n. So n is nothing but lambda by hc. Let's put the value. 4,000 picometer is 1 picometer is 10 to the power minus 12 meter. So I just convert into meter. H is Planck's constant 6.626 into 10 to the power minus 34 joule second, into c is the speed of light 3 into 10 to the power 8 meter per second. So if you solve this, you get 2.012 into 10 to the power 16. That is the number of photons required to produce 1 joule of energy. A photon of wavelength 4 into 10 to the power minus 7 meters strikes a metal surface. The work function of metal is 2.3 eV. And we define the energy of photon in eV, kinetic energy of emission, and the velocity of electrons. This is the metal. This is my photon which strikes on this. The wavelength of photon is given. We can find the energy of photon in joule. But you define EV, so you can convert that into EV by doing this conversion. So let's first find the energy of photon. So energy of photon is nothing but hc by lambda. Put the value of h, Planck's constant 6.626 into 10 to the power minus 34 joule second. C is 3 into 10 to the power 8 meter per second, and then by lambda divided by lambda is 4 into 10 to the power minus 7 meter. So if you solve this, you get something 4.9695 into 10 to the power minus 19 joules. But we don't want in joules, we want in EV. So 1 EV is equal to this many joules. So if you divide this guy by 1.6020 into 10 to the power minus 19, you get the answer in EV. Electron volt, this is nothing but 3.1020 electron volt. So energy of photon is 3.1020 electron volt. What we want? We want, this is done, we want the kinetic energy of emission. So kinetic energy of emission is nothing but energy of photon minus my work function of metal, W function of metal, because this much is the energy required to take out electron and this much energy we are giving. The balance is the kinetic energy. This is nothing but 3.1020 minus 2.13 eV, right? That is 0.9720 electron volt. That is my kinetic energy of emission in electron volt. The next question is, we have to find the velocity of photoelectron. This is my kinetic energy. So kinetic energy is nothing but half mv square. This is my kinetic energy 0.9720. This is in electron volts. I'll convert this into joule. So 1 electron volt is equal to this many joules. So we'll multiply with this guy by 1 into 10 to the power minus 19. And this is nothing but half mv square. So v is nothing but root of 2 into this whole number 0.9720 into 1.6020 into 10 to the power minus 19 by m. Mass of electron is something we know, that is 9.16939 into 10 to the power minus 3 kg. So if you solve this, you get 5.84 into 10 to the power 5 meter per second, and that is my answer. That is the velocity of electron. Easy only. See what we have done. We found the energy of photon in eV. This much energy we gave. Out of this much energy in eV is used by the metal to kick out electron. That's the work function of metal. So balance energy is the kinetic energy, right? And then I found the velocity of the electron. Electromagnetic radiation of 242 nanometer wavelength is thus sufficient to ionize sodium atom. Calculate the ionization energy of sodium in kilojoule. So if you see, the question is we have to give the energy in kilojoule per mole. That's the only difference here, because the wavelength is given. I can find the energy very easily. Correct? See, energy of one molecule of, or ionization energy, I energy of one molecule of sodium will be Hc by lambda. Correct? Where H is my 6.626 into 10 to the power minus 34 joule second. C is 3 into 10 to the power 8 meter per second. And lambda is a wavelength, that is 242 nanometer, that is 10 to the power minus 9 meter. This is the ionization energy of one molecule of sodium. I am talking about ionization energy of 1 mole of sodium. That is nothing but 1 mole is nothing but 6.023 into 10 to the power 23 molecules. So this is nothing but this into ionization energy of one molecule. Hope you understand this. Ionization energy of 1 mole of sodium is 6.023 into 10 to the power 23 into ionization energy of one molecule, and that is here. So you solve this, you get 6.023 into 10 to the power 23 into 6.626 into 10 to the power minus 24 joule second into 3 into 10 to the power 8 by 242 into 10 to the power minus 9. So we solve this, you get 494.7 into 10 to the power 3 joule per mole. I am looking in kilojoule per mole, so I'll make it 494.7 10 to the power 3. I'll make it kilojoule per mole. See, the trick was it asked for per mole. We found the ionization energy per mole. It asked in kilojoule, so we converted joule to kilojoule. Correct. 25 watt bulb emits monochromatic yellow light of wavelength 0.57. Calculate the rate of emission of quanta per second. See, 25 watt, we have done this similar kind of question. 25 watt means nothing but this guy is giving 25 joules per second. Correct? And this gives a light of wavelength this. So energy of one photon molecule is how much? Sc by lambda. So we'll put the values 6.624 into 10 to the power minus 34 joule second. C is 3 into 10 to the power 8 meter per second, and lambda is 0.57 into 10 to the power minus 6 meter. So we solve, we get 34.87 into 10 to the power minus 20 joules. This is energy of one photon. Please note, energy of one photon. So energy of one photon is this, and I am saying that per second my bulb is emitting this much energy. So to emit this much energy, I need some n number of photons. That means 25 joule is nothing but some n number of photon into this energy. Correct? Because some n photons will give this much energy. So if you want to find the value of n is nothing but 25 by 34.87 10 to the minus 20. You solve this, you get 7.169 into 10 to the power 19 photons per second. This is the number of photons that are emitted by the bulb per second to make sure that 25 joule of energy is released per second. Electrons are emitted with zero velocity from a metal surface, that means kinetic energy is zero, when it is exposed to radiation of wavelength 4800 Armstrong. We define the threshold frequency and the work function of the metal. So if you see, this is the metal, this is my radiations, there is no kinetic energy. So if you see energy, I can say energy of photon is equal to kinetic energy of electron that comes out plus electron comes out, right, plus my energy, or I can say work function of metal, because this is the energy required to remove a electron from the metal. This guy is zero because the velocity is zero. So energy of photon is nothing but work function of the metal. So I can find easily work function of the metal, correct? So the first thing is you have to find the frequency. Frequency also will be nothing but c by lambda. And what is the value of lambda? C is 3 into 10 to the power 8 meter per second. And lambda here is, this guy is 6800 Armstrong, convert into meter. So I'll get 68 into 10 to the power minus 10 meter. So if you solve this, you get 4.41 into 10 to the power 14 hertz, you can say. This is the frequency, right? Find the work function. Work function will be nothing but energy of photon, that is nothing but h mu naught, that is 6.626 into 10 to the power 34 joule second is the value of Planck constant, into the mu naught we got is 4.41 into 10 to the power 14 hertz, right? So you solve this, you get 2.922 into 10 to the power minus 19 joule. This is the one. See, the trick part here was the kinetic energy is zero, so this velocity is zero, so this part becomes zero. That is something which you have to understand.
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.